There are three states of matter that you need to know about, and they're solid, liquid, and gas. They can be represented using a simple model which shows solids with spherical particles which are closely packed in a regular structure. These particles vibrate about a fixed position and have very strong forces or bonds between them. This means solids keep a fixed shape and cannot be compressed. Liquids also have closely packed particles. However, these are not in a regular structure and they are free to move. They have weaker forces between the particles. This means liquids do not keep a fixed shape, and because their particles are still very close together, it's hard to compress them. Gases have particles that are far apart in an irregular structure with particles that move rapidly in random directions. They have the weakest forces between the particles of the three states, and they can't keep a fixed shape but can be compressed. Using this simple model of small spheres to describe states of matter is useful, but it does have some inaccuracies. In reality, these particles, which represent atoms, ions, or molecules, aren't always spherically shaped. This simple model also doesn't show the actual forces between the particles, so there's no way of knowing how strong they are. State symbols are used in chemical equations to indicate the state of a substance. An S in brackets represents solids, an L represents liquids, and a G represents gases. An AQ stands for aqueous, which is anything that's dissolved in water, so for example acids or other solutions. Substances can change states between solids, liquids, and gases, and these processes involve energy changes and particle movement. So when a solid is heated to its melting point, its particles gain energy and vibrate more. This weakens the forces holding them together. This process is known as melting, and it turns solids into liquids. Heating a liquid further to its boiling point gives the particles even more energy to move even more faster. This leads to boiling or evaporating, where the liquid becomes a gas. If we go the other way around and we cool a gas down to its boiling point, the particles lose energy and form bonds. This causes the gas to turn into a liquid and is known as condensing. When the particles in a liquid are cooled even more to their melting point, they lose more energy. This causes them to move less and form more bonds between them, causing the liquid to become a solid, and this process is called freezing. The amount of energy needed to change from a solid to a liquid and from a liquid to a gas depends on the strength of the forces between the particles. The stronger the forces between the particles, the higher the energy needed to melt or boil the substance. You can predict the state of a substance at room temperature by using its melting and boiling points. Below the melting point, a substance is solid. Above the boiling point, it's a gas, and between these 2 points, it's a liquid. So here's some examples of substances and their melting and boiling points. You can predict what state they are at room temperature, which is 25 degrees, by seeing whether 25 degrees is bigger or smaller than these values. Okay, now let's try a quiz on this topic. See how many questions you can get right. If you liked that video and want to see more, remember to subscribe to Flash Revision Lab to to get notified every time we release new content.